All right, here in this lesson, we're going to be covering operations in scientific notation, more dividing and multiplying, like we've been doing, but now we're including adding and subtracting. So first, deuterium and tritium are hydrogen atoms. You can talk to Mrs. Lay or Mrs. Rolk about these. Deuterium contains one proton and one neutron. That and, we should know, and in math means to add. So we're thinking about adding a proton and a neutron. One proton has a mass of that many grams. One neutron has a mass of that many grams. Let's go ahead and add those together because it says one proton and one neutron to make this deuterium. So we're going to take 1.6726 and we're going to add 1.6749, and that gives us 3.3475. Now, the reason why we can add these together is because right there. When we add and subtract numbers, we can only add and subtract numbers that are like terms. You can't take 2 and subtract it from x. Those aren't like terms. You have to make them like. So here, when we are using or adding and subtracting numbers in scientific notation, the like terms is our exponent. If we have the exact same exponent, then we can add and subtract them. So I'm allowed to add and subtract these, the mass of a neutron and a proton, because their exponents are exactly the same. So there I have added them. When we add and subtract numbers in scientific notation, in the answer, our exponent stays the same. We do nothing with the exponent when we add or subtract in scientific notation. Now we add in tritium here, and we want to know what the difference is. So we are going to take our tritium and subtract it from the number we got before. So the first thing I'm going to look at is my exponents, or are my exponents. If they are the same, I can just go ahead and subtract them. And in this case, they are exactly the same. Therefore, I can go ahead and just subtract these numbers because I have like terms. So I take the numbers in front and subtract them. I get 1.6749, and then times 10. Now, again, these are like terms, so our exponent stays the same. And there is our final answer. So here we go again. I want to simplify this. First thing I'm going to look at are my exponents. They are all the same, which is awesome. So now I can go ahead and add all these two numbers together and then subtract that one. So first, let's take 5.9 and we're going to add it to 4.3. I get 10.2 times 10 to the fifth. Now you might be saying, well, that's not scientific notation. That's good that you recognize that. We don't care until the end for our last number to be in scientific notation. Times 10 to the fifth. Again, exponents are still the exact same. So now I'm going to go ahead and subtract 2.2, and I get 8 times 10 to the fifth. Okay, now, is it possible to add and subtract numbers in scientific notation when they do not have the same power of 10? Yes, this is possible. Okay, because when we move the decimal, that changes the exponent. So we can always move the decimal of one number until the exponents are exactly the same. So we're going to scroll back up. I'm going to give you a real quick, let's do 3.2 times 10 to the 6th plus 7.8 times 10 to the 5th. Two numbers, different exponents, right? I can't add them yet. So I need to make my exponents the same. So if I wanted to, now you can pick and choose. It doesn't matter which one you pick. Let's just say I want to make that one a 5. I want to make this number, this exponent right here, smaller. That means I need to make this number bigger. So if I make my exponent smaller by 1, I make the number in front bigger by 1. So this becomes 32 times 10 to the 5th plus 7.8 times 10 to the 5th. Now I have the exact same exponents, so I have like terms. I can add these together. I get 39.8 times 10 to the 5th. Okay, you might be saying this first number is not in scientific notation. That's okay. Now in the end, we want to put it in scientific notation. I'm going to make this number smaller, which means I need to make my exponent bigger. There is my final answer. So that is how you would add or subtract, and possibly subtract numbers using scientific notation with different exponents. So carpet contains dust mites. Suppose the length of a dust mite is right here. If a carpet has 1,000,000 of these and they're all lined up, how long would that line be? Well, in order to find out how long, here's the length of one dust mite. Here's how many dust mites there are. We want to find out how long. We're just going to multiply. Now, exponents don't matter when multiplying. They don't have to be the same because, let's do the number in front first. I get 1 times 2.5, which is 2.5, because when I multiply like bases, like here with my tens, I add my exponent. So negative 4 plus 6. So I get 2.5 times 10 squared. If we wanted that in standard form, there we put a 2, so that'd be 250. There's about 1 times 10 to the 8th bacteria living in a human body, and there are about 2,000 students at Hastings Middle School. How much bacteria is living on students at the school? We're going to take the number of bacteria. Let's take the number of students, put it in scientific notation. 2 times 10 to the 3rd. I'm going to take these two numbers and multiply them. 1 times 2 is 2. And then when I multiply like bases, I add my exponent. So I have to do 8 plus 3, which equals 2 times 10 to the 11th. That's a lot of bacteria. So the size of a beetle is that many meters long. They stood in a line that was that many meters long. How many beetles will there be? Well, I know that, let's do 1.25 times 10 squared. I know that the beetles are standing in a line that's this many long. This is the length of one beetle. So I need to divide to see how many beetles there are. So I'm going to take 1.25, divide it by 3.1, and I'm going to get 0.4, I'm going to round there, times 10. Now when I divide like bases, I subtract my exponents. So it'll be 2 minus negative 3. Minus a negative means plus a positive. So I get 0.4 times 10 to the 5th. Not yet in scientific notation. That's 4. I made this number bigger, so I need to make this number smaller. Or if it wanted just to know in standard form, which it probably does, I need to move this 4 more, which tells me there would be 40,000 beetles standing in line. The largest stars are known as red supergiant, and Betelgeuse is a red supergiant and is really big. It's actually bigger than 1 astronomical unit. We want to know what the width of Betelgeuse is. So, I'm going to take the width and divide it by an astronomical unit to see, or how many miles of an astronomical unit. So we get 3 divided by 9.3, which gives us 0.32, and I'll round it there, times 10. Now when I divide like bases, I subtract my exponents. So 0.32 times 10 to the 1st. Let's put this in standard form. So it is 3.2 times as large.